So should we start?
Yeah, making live.
What are you making live? The logo, huh? No, let me directly go live, no? I have a blank slide, right? Hello boys and girls, a very good morning and welcome to this live session on Speed Math Part 4 brought to you by TalentSprint. I hope all of you are in good health and you're fully geared up for all your upcoming bank and SSC exams. I think we are on 13th of October today, and the next two days for your IBPS PO preliminary examination for the year 2017 are tomorrow and day after. So I'm sure a lot of you here are going to have your IBPS PO prelims exam either tomorrow or day after in one of those 4 shifts each day, right? And many of you would have already finished it in the last weekend itself. So I think before we get into the discussion today, I would like to understand about your confidence for this exam, and those who have taken it can probably tell me about how did they perform in the exam last weekend, right? You know that this is the first round in the recruitment process for IBPS PO, which is a preliminary examination, and whoever qualifies this will be called for the main exam, right, which will be held sometime in November, right? And then final round is going to be your interview. So what is your confidence if you have your exam tomorrow and day after? I think you should be fully confident. There is no choice, right? I mean, you should build that confidence up, keep yourselves calm, composed, cool, right? Ensure that you spend a lot of time relaxing now and you know, get mentally ready for that 1 hour of your examination. And those who have done it should continue with their preparation for the mains exam and other upcoming exams. Yeah. So Saurav Sahil says he has attempted 55 questions. Okay. How about others? I see that a lot of you have joined the chat, by the way, right? Abhas Pandya, Swami, Jay Rocks, Viresh, Rajesh Sharma, who has attempted 68 questions, right? And Viresh, by the way, has got his exam tomorrow. So all the best, Viresh. I hope you do well. Yeah. I think the only advice I have for Viresh and all those who are going to take the exam tomorrow is to now relax, right? This is high time that you cut your preparation completely and just keep yourselves, you know, cool and don't panic, right? We have Sandesh Sharma who's attempted 70 questions. Amanjot says he has done 47. Harish has attempted 40. Harichandan has got the exam tomorrow. Rajeshwari has got the exam tomorrow. Yeah. Vijay has attempted 60 questions. Good. So I think 60 is what the average looks like, right? I mean, based on this chat today and all the earlier discussions that we have had. Okay. So let's hope for the best. I think your attempt is over. All we can do now is continue with the preparation for the mains exam and just hope for the best. Let the best one get called for the next round here, right? Now I'm sure that many of you are also appearing for your IB Intelligence Bureau's ACIO exam, right? The Assistant Central Intelligence Officers exam, which is, I guess, scheduled for the 15th of October, day after tomorrow again, right? So there also the strategy remains the same, right? You have to keep yourselves cool and, you know, go and give your best in the exam. We have had one free session on previous year's paper discussion of IB's ACIO exam, which was done by Gayatri. So if you have missed that session in any case, you can go back to our YouTube channel and watch that particular video. All right. Now, should we get started with the discussion for this session today? Uday says tomorrow is my turn to attend the exam. All right. All the best. Rahul says, after SBI PO preliminary exam that I had cleared, I failed all the exams including Bank of Baroda PO, IBPS RRB, IBPS clerk, IBPS RRB clerk, and I feel nervous. So what do I do? See, Rahul, you got to understand, Rahul and everybody there got to understand that success and failure is a part and parcel of this game, right? I mean, you will win some, you lose some. Good that you have cleared the SBI PO preliminary examination, which is considered to be the toughest exam in the country, right? So I really appreciate that. But on the other hand, you have flunked in the other exams, I guess. So not to worry, don't give up. I think the only advice I have is don't give up. Don't refuse to get back, right? Continue your preparation, you will crack it very soon. All right, so let's get into the discussion for the session today. We are going to talk about something on speed math, right? I mean, you know that we are meeting every Friday at 11 a.m. to discuss maybe one technique from speed maths or Vedic mathematics, so that you can, maximize your score in the quantitative aptitude section, right? All of you must understand that every question in quantitative aptitude involves numbers, and if you cannot play with these numbers or do the simplifications quickly without putting pen on paper, then you will lose out on some marks there, right? You may clear the cutoff score, you may get a call for the next round, but then this is one section, quantitative aptitude, where you can maximize your score. It is actually a score booster, but many of us fail to realize that because we end up wasting a lot of time doing paperwork, right, when you are dealing with numbers. So to help you get out of this problem, we have started this series which happens every Friday at 11 a.m. covering something on speed math. So we have done 3 or 4 sessions, if I'm not wrong, already, and this should be the 4th or the 5th one. And what we are going to do today is, I think, let's look at squares. We have done something on additions and subtractions. We have done percentage-based calculations. We have done multiplications in our earlier sessions. Today, I think, let's focus on squares. How do you find out square of a number, right? What can be done to get the square of a number? Now, square of what numbers? Well, anything can be asked in the exam. They can ask you 37 square, they can ask you 4226 square. Yeah, but what is most likely is these 2-digit numbers and 3-digit numbers, right? I mean, this is where you need to, you need to kind of sharpen your tool and understand how can you get the answer quickly. If it is a 4-digit number, it is actually complex. We are better off doing it on paper, right? But at least 2-digit squares or 3-digit squares need not be done on paper always, right? There are methods, there are techniques which can help you get the answers in a jiffy without doing any paperwork. You just have to spend about 30 minutes to 60 minutes. I mean, a maximum of 1 hour in practicing this technique, right? And you will master it, right? Now, again, whether you follow this technique that I'm going to explain you now or any other technique doesn't matter. What matters is stick to something and practice enough so that you're able to apply it during the exam, right? At the right time. Learning too many techniques is not going to help, right? Same calculation can be done in 10 different ways. Find out which is the one that works best for you and keep practicing on it so that you can really apply very quickly in the exam. Okay. Now, I am going to discuss a technique which is simple in my view, right? And all we have to do here is break the number into 2 parts. And I have discussed this multiple times, right? Any arithmetic calculation, I mean, be it multiplication or addition or subtractions or divisions, or for that matter, square, square root, cubes and cube roots, or percentage based calculations, can be done using this interesting technique called split and merge. Split is to break and then merge is to combine, right? So split the numbers, do the individual calculations, and then merge. There may be 2 or 3 terms that you get, merge all of them to get the required answer. So let us look at something similar today. But then there is a prerequisite for you to be able to apply this technique, right? I am sure most of you will already be you will have this prerequisite satisfied. The number 1 item here is that you should know 1 to 30 squares by heart, right? You should learn 1 to 30 squares by heart. It should be on your fingertips. Like for example, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16, all of us know. But what is 23 squared? 529. What is 27 squared? 729. What is 25 squared? 625, we know that. But what is 21 squared? You should not take a second to mark the answer there. 21 squared is 441. It should be like your name, right? I mean, what's your name? Comes the answer, right? Without any second thought, right? What's your name? You don't take time to think about your name, right? Rohit Agarwal, right? So that's how it should be. 1 to 30 squares on your fingertips at any point of time. I mean, it should just come out the moment it is required, right? 18 squared, you should not think about it. 18 squared, you should know what the value is. right? 20 squared, 400 we know. But 19 squared, if you observe, we take about a second. What is 19 squared? That struggle should not be there. So spend some 5 minutes, learn 1 to 30 squares by heart. That is it. You don't have to do anything else. 1 to 30 squares, if you know by heart, you're through. You can find out squares of any other number by some practice after this, right? So 1 to 30 squares, you have to learn. You must learn. The other thing that you must know, and I'm sure all of you would know, is this very basic algebraic formula of a plus b or a minus b the whole square, right? A plus or minus b the whole square. We have learned this like in 8th, 9th standard, and I'm sure all of us remember it too, right? A plus b the whole square. What is the expansion? A squared plus 2ab plus b squared. Or for that matter, a minus b the whole squared, right? A minus b the whole squared. A squared minus 2ab, a squared minus 2ab plus b squared, right? So these are the two things, 1 to 30 squares and a plus or minus b whole square is what you need to know. Now, all of you would know some special techniques, like I can see somebody commenting here that 41 to 50 squares can be calculated very easily. There is a trick. So there can be tricks which are applicable for a specific set of numbers, like 41 to 50, or for that matter, finding out squares of numbers which are close to 100 is very easy. But that is applicable only when the number is close to 100. Finding out squares of numbers that end in 5 is like a no-brainer, but applicable only when the number is ending in 5. What we have to discuss or what we have to learn is what is that technique which is applicable throughout. Learning those special techniques is useful. I don't say that it's not useful, but don't depend solely on that, right? It has got its limitations, right? So let's discuss something which is general and applicable always across all the numbers. Okay. Again, we'll not look at very high numbers. Let's get the basics right first. Smaller numbers. How do you find out 57 square? How do you find out 57 square? You don't have to learn it by heart. Don't try to mug it up. What you have to mug up is 1 to 30 squares. But 57 square, 2 seconds, you will know the answer. 3249. Again, I did not memorize it. I was doing the calculation myself, right, in my heart there. And you should be able to do that calculation and get the answer, right? For example, if you need 61 square, I would say 3600 plus 120, 3721 is the answer. And because I'm trying to speak it out, it takes maybe 1 or 2 seconds extra. Otherwise, if I do it within myself, the answer comes much faster. See, I'm not trying to brag about my skills that I can find out squares very quickly. All I'm trying to say is if I can do this, even you guys can do it. Yeah, I need 72 square, 50 plus 22, so 2500, 4700 plus 484, 5184 is the answer. Again, I am speaking it out, so a couple of seconds extra, otherwise even faster. So let's understand how can you do these calculations of simple numbers, or even it can be a bigger number like 109 square, 153 square, 206 square, 184 square. You can do it in like 3 or 4 seconds. So what I will do now is, write something and explain this to you. You need not put on pen on paper. I'm just writing it so that you can understand and follow it very clearly. But practice enough and make sure that you are able to apply it yourself. Okay. So I'm sharing my screen now, where I'll explain you this technique. So here we go. So what we are going to discuss today is about squares, right? How do you get square of a number? Just a second. Here we go, finding out squares. Okay, now like I said, number one, you should know 1 to 30 squares by heart, right? Learn by heart. Right, and second requirement is a plus or minus b the whole square expansion. You know what it is, right? A squared plus or minus 2ab plus b squared. Now this is what is split and merge in my view. What we are going to do now is split these numbers. When any number given to you, split it in the form of a plus b or a minus b, and then use the expansion to get the answer. See, this looks complex, that why do we have to do a square, b square, 2ab? The number of terms are 3, but then calculating each term would be very easy, and then just adding them up will give you the required answer. Are you getting it? So I'm hoping all of you know 1 to 30 squares, and of course you know what is a plus or minus b the whole square. Now let's take an example. For example, let's say I got to find out 62 squared. 62 squared. Now 62 is a number. 62 is a number. I want this number to be split as a plus b whole square or a minus b whole square. Tell me what's the idea that you get. Let's say, and I'm sure many of you would say that we better take it as 60 plus 2. Let's see what happens. 60 plus 2 the whole square. 62 can be taken as 60 plus 2. Now what happens? 60 plus 2 whole square. See, a is equal to 60, b is equal to 2. So substitute now and get the expansion. 60 squared, a square is 60 squared, plus 2 into 60 into 2 plus 2 squared. Now try and follow this. I'm not saying this is the best way to get the answer. Just follow what happens here, and then we'll try to improvise on the technique. Okay, so 60 squared plus 2 into 60 into 2 plus 2 squared. Now finding out each of these terms is very easy, right? I mean 60 squared you all know is 3600. I mean if 6 squared is 36, 60 squared would be 3600. 2 squared is 4. These are like no-brainers. All you have to do is this multiplication. So if you see a squared and b squared, always a squared and b squared will be known to us. These are not difficult. Where we actually have to spend some time is 2ab part. Plus 2ab or minus 2ab. So do that now, 2 into 60 into 2. Not very complex, but you have to spend some time, right? 2 into 60, 120. 120 into 2, 240. 240. So 3 terms, add these and get the answer, right? So 3600 plus 240, 3840. 3840 plus 4, 3844. Yes or no? 3600 plus 240 is 3840 plus 4, 3844. You've got it. Now the same thing has to be done without paper. Can be done. I'm sure it can be done. But however, I would still say that this is not the best of the ways to get the answer. You've got the right answer. 3844 must be the right answer. But then there is a better way of arriving at the same answer. What can be done? Understand. The same 62, let's expand it as, instead of 60 plus 2, let's take it as 50 plus 12. Now, initially it may look like even more complex, right? 50 plus 12 looks like not the best way to expand it, best way to split it. 60 plus 2 is easy, right? 60 and 2. Rather than 50 and 12, but then there is a hidden advantage here. So let's understand that hidden advantage. What happens? 50 plus 12 square. So what happens again? A plus b whole square, right? So a squared 50 squared plus 2 into 50 into 2 plus b squared is 12 squared. So like in the previous case, 60 squared 3600, here 50 squared 2500. Not very complex, right? 2500. It was 2 square earlier, 4, 12 square 144. Anyway, we know what is 12 square. I mean, for us, 12 squared is as good as 2 squared. Both of these values have been memorized, right? We have learnt it by heart. So, doesn't really matter whether it is 2 square or 12 square or 22 square. Like if it is 22 square, 484. It's just that it is a 3-digit number as against a 1-digit number. Yeah. Now comes the second term. Look at the second term. What is the second term? 2 times 60 times 2. 2 into 50 into 2. Earlier it was 2 into 60 into 2. Now it's 2 into 50 into 2. Multiply 2 into 50, 100. 100 into 200. So this becomes 200. Right? This becomes 200. Now add. Sorry, this should be 12. I'm sorry. I think I missed on this part. 2 into 50, 100. 100 into 1200. Right? Now add the 3 terms. 2500 plus 1200. 3700. 3700 plus 144. 3844. Same answer, right? And in my view, this is easier, 3844. Now, some of you might be wondering, how is it easy? How is it anyway easy? It's the same expansion, right? Here we had 60 square, here we have 50 square. There we had 2 square, here we have 12 square. There we had 2 into 60 into 2, here we had 2 into 50 into 12. So, what is so different about it? Let me tell you that actually this expansion is not needed. You don't have to really do this expansion when you use 50 as the base value. See, the point here is, if you closely observe, you don't really have to do this second term's calculation. First term and third term are very easy. Those values are known to us. Where are we spending time? In multiplying the, in getting the product, which is the second term. But then this can be done directly when you take base as 50. Understand, what is our second term? 1200, right? Observe, what was B? 12. Multiply 12 with 100, you'll get 1200. So basically the point is, when you take the base A as 50, whatever is B multiplied with 100 will give you the second term. Why does this happen? Simple. A plus B the whole square, right? Let me expand it as 50. Let me take it as 50 plus B whole square. That's what you're doing. 50 plus B whole square or 50 minus B whole square. What happens? 50 squared plus or minus 2 into 50 into B plus B squared. So if I simplify, 50 squared 2500. No wonder about that. I mean, no second thoughts on that. Plus or minus 2AB, 2 into 50, 100. This is 100B and plus B square. So if you actually see, when I fix A as 50, what are we doing here? We are fixing A as 50. When you fix A as 50, the first term is always 2500. So you don't really have to calculate. Like otherwise it could be 60 square or 70 square or 80 square or 40 square. But here I don't have to calculate because first term is always 50 square, which is 2500. Last term is anyway B square. Anyway has to be done. Second term becomes very easy. It is plus 100 into B or minus 100 into B, depending on plus B or minus B here. So if B is 12, second term will be 1200. If B is 14, second term will be 1400. If B is 19, second term will be 1900. If B is minus 4, second term will be minus 400. If B is minus 6, second term is going to be minus 600. You don't have to put pen on paper for that. So first term 2500 fixed, second term plus or minus B into 100, third term B square. As simple as that. Because 2 into A, when A is 50, 2 into A becomes 100. So it becomes 100B. It becomes 100B. You're getting it? Now this is a very generic technique applicable across. You don't have to worry about number being a number ending with 5 or not, or numbers are closer to 100 or not. You can always apply this. Let's take some examples now, right? Let's look at some examples. For instance, let's say I have to find out 67 square now, let's say. What do we do? 2500. Now, I'm not writing the breakup here. 67 will be taken as 50 plus 17. That's the idea, 50 plus 17. So 2500 is fixed. Because it is plus 17, we'll take 1700. And b square, 17 square. What is 17 square? 289. That's your answer. Now you have to add these terms. 2500 plus 1700 is 4200 plus 289, 4489. That's your answer. 4489 is your answer. I am putting it here so that you can follow. When you do it yourself, you have to do it mentally without taking pen on paper, without putting pen on paper there. You're getting it? 2500 because 50 square, 1700 because it is plus 17 into 100, and 289 because it is 17 square. So 2500 plus 1700 is 4200 plus 289, 4489. Now let me cut down the steps further, right? Let's not even write this. Let's try to do it directly. I have to find out 72 square. What happens? 2500 is fixed. Now 50 plus 22. See, the only thing that you need to find out is what is b. B is 22. 50 plus 22. So 2500 plus 2200, 4700 plus 22 square. What is 22 square? 22 square is 484. So 4700 plus 484, 5184 will be the answer. Because I am speaking it out, it has taken 5-6 seconds. When I do it mentally, I'll be getting the answer much faster. You're getting it? I have to find out 57 square. Take this. I mean, let me clear up the screen. Or let me do it here, right? 57 square. What do you do? 50 plus 7, you're done. 50 plus 7. So 2500 plus 700, 3200 plus 7 square, 49. 3249 is the answer. You don't have to memorize it by heart. You don't have to memorize it by heart. You're getting it? It is 50 plus 7. So 2500. Because it is 7, it is plus 700. And 7 square, 49. These three terms. What happened in this case? 72. It was 50 plus 22 whole square. So 2500 plus 2200. Avoid writing these steps basically. And 22 square, 484. Now don't ask me how should I know 22 square is 484. I told you minimum requirement is 1 to 30 squares. You should learn 1 to 30 squares by heart. Yeah. Let's say I want 46 square. What do you do? Same technique. The only difference is 46 is 50 minus 4. So what happens? 2500 remains 2500. Instead of plus 400, you have to take minus 400. Plus 4 square, 16. See, remember, plus or minus 2ab. B square is always positive. So 2500 minus 400. 2100 plus 16. 2116 is your answer. Do we have to put steps on paper for this one? No. 46, 50 minus 4. So 2500 minus 400, 2100 plus 16, 2116. You're getting it? Let's say we got to find out 41 square. 41 square. Tell me what the answer would be. 50 minus 9, right? So 2500, because it is minus 9, minus 900. 2500 minus 900 is 1600 plus 9 square. You have taken 9, right? So 9 square, 81. 1681 is your answer. That's it. It will take half an hour to master this technique. Let me tell you, it is not going to take more time. Just half an hour to master this technique. What do you have to do? Break the number with a base as 50. 50 plus something or 50 minus something. 50 plus or minus something, and just play with that. First term 2500, second term b into 100 plus or minus, and third term is b square. Done. Now, limitations here also. While the technique is applicable for all the numbers, as you move forward, if you take larger numbers, it gets, it gets more and more complex. Yeah. Like for example, let us take a couple of examples before we go for a larger number. Let me just test out if you guys have followed it. So tell me what would be 59 squared. Time is up. That's it. You need just this much of time to get the answer. 59 squared. 2500 plus 900. 3400 plus 81. 3481 is the answer. No? 2500 plus 900 plus 81. Prasanna Patra says, I remember squares up to 99. Why? Why do you have to spend, why do you have to block some part of your brain in mugging up those squares up to 99? You don't have to. And what do you mean you remember squares up to 99? 100 also you can remember. No, 100 square is 10,000. So why do you say up to 99? Up to 100 you say. But see, Prasanna, you got to understand that where would you stop? Where will you stop? In the exam, he may ask you 102 square. Do you have a technique for this? No. Because you have learned only up to 99 or only up to 100, you have this limitation. But if you know a technique which can help you find out even bigger numbers, it will be a lot easier, right? We have not gone to bigger numbers yet. We are only in the range of 70s, 80s, right? The moment we cross 80, this technique would get complex. So we'll get to that. But the point is, at least up to 80 square, you should be able to find it easily. Now, why am I saying that only up to 80 this works? It actually works beyond that also. But the problem is, we know only up to 30 squares. I have learned only up to 30 squares. If I know what is 31 square, I can find out 81 square also very easily. If I know what is 36 square, I can find out 86 square very easily. You're getting it? Anyway, let's take one more example. So 59 square, I hope all of you have got the answer, right? 59, 2500 plus 900 plus 81. 3481 is the answer. Let's say it is 67, did we do? 67 you have done. What do we do? 66 square. What is 66 square? Find out. 66 squared. Take as much time as you want. While I say that it can be done in 2-3 seconds, you take as much time as you want. 66 squared. Do not put pen on paper. The whole idea is not to put pen on paper. Yeah? 66 squared. What do you do? Mentally, base is 50. So 66 becomes 50 plus 16. 50 plus 16. 2500 plus 1600 plus 256. Merge these terms. And additions we have discussed, right? How to add numbers. So it should be easy. Yeah. So do that. I think you essentially have to do that. 2500 plus 1600 plus 16 square, which is 256. So 2500 plus 1600 is how much? 4100 plus 256, 4356. I have not memorized the answer. I am doing it here, right here. And if I can do it, I am sure you guys can also do it. 4356. I'm glad that all of you have got the right answer. And I'm sure none of you have used a calculator or anything there, right? 4356. Yes, 4356 is the answer. And today, if you are able to do it in, let's say, 5 seconds, 6 seconds, 10 seconds, when you spend some more time, you'll get the answer really quick, right? Even faster. This is a new technique that you will learn, right? A little bit of practice will improve your speed. Okay, I think time is up. We have to close it here, but let me explain you how to extrapolate the same technique and do it for bigger numbers. Now, why does this work only up to 80? See, we have taken the base as 50. What did we say? Our base is 50. So if it is 79 square, if it is 80 square, you don't have to do 50 plus 30, right? 80 square, you know, is 6400. But if it's 79 square, what do you do? 79 is 50 plus 29. Fine. 2500 plus 2900, 5400 plus 29 square. What is 29 square? 841. So 5400 plus 841, 6241 is your answer. Up to that it works, right? Because everything is just about addition, right? Squares is no more a square calculation, right? It's just addition of 3 terms. What happens if you go beyond 80? Let's say I take 82 squared. Now if the base is 50, 50 plus 32. So 50 plus 32 gives you what? 2500 is fine. The first term is fine, 2500. Because it is plus 32 plus 3200 is also fine. No problem. The problem comes in the third term. What is the third term? 32 square, which I don't know. Do I know what is 32 square? No. My limitation is up to 30. I mean, I have not learned 32 square. And honestly, I don't know what 32 square. I mean, I know it is 1024 because I've come across that multiple times. But, on paper, I would say I don't know what is 32 square. Now, if I don't know how to find out what is 32 square, I cannot find out 82 square because I don't want to do any more calculation there. I just want to do additions. These 3 terms are like known to us. 2500 is always known to us. B into 100 is like readily available. And B square should also be readily available. But 32 square is not available to me readily. Yeah. So what do we do? Then you cannot take the base as 50. Either you learn what is 32 square. I mean, learn up to 40. If not 30, learn up to 40 or learn up to 50. But why? In my view, up to 30 is more than enough. What you can do is, when you cross 80, change the base. Change the base from 50 to 100. Change the base from 50 to 100. There's a slight change in the calculation, and then otherwise everything remains the same. When you move from 80, when you go beyond 80, just change the base. So let me explain that to you. What happens there? What do we do? Now, in this case, we have taken a plus b. A plus or minus b the whole square, you've taken a as 50. There you take a as 100. So 100 plus or minus b the whole square. Expand it. You know what is a plus b whole square, right? Or a minus b whole square. Just expand it. So what happens? 100 plus or minus b whole square. 100 square, 10,000. Currently the first term is 2500. When you take the base as 100, the first term will become 10,000. Yeah. Now 2ab part. What happens in 2ab part? 2 into a, which is 100 into b. So 200 into b. So far it was 100 times B, now it is 200 times B. So basically double of B times 100, double of B times 100. Currently it is B into 100. When you take base as 100, double that B and then multiply by 100. Yeah. And the last part is B square, which remains the same. And you're done. So let me explain that to you now, right? Let's take a couple of examples to understand that, and then similarly you can go up to 130. Then beyond 130 you may have to take the base as 150 and so on. So I'm just clearing it up to explain you what happens if it is a bigger number. So squares again. Okay. Let me just, I'm sorry, I have this OCD, if you understand, right? I have to write it neatly. Okay, so now let's see what happens if it is 100 plus or minus b the whole square. 100 plus or minus b whole square. So 100 squared plus or minus 2 into 100 into b plus b squared. So you see b square is same from the last technique, no change. The change is that in the earlier case, when you take base as 50, the first term was 2500. Now the first term becomes 10,000. It is 10,000, right? So instead of 2500, it is 10,000. Plus or minus, look at this part. 2b into 100. Don't take it as 200 into b. 200 into b sounds complex, but 2b into 100 is easy. Earlier it was b into 100. Now it is 2b into 100 plus b squared. That's it. Let's take an example. The same 84 squared. Or let me start with something more than 100. Then we'll come to 84. Let's say I have to find out 109 square. What do you do? 100 plus 9. Don't take it as 110 minus 1. Right? 100 plus 9. So 100 plus 9. 100 squared plus 2 into 100 into 9 plus 9 squared. So 10,000 plus 2 into 9, 18 into 100, 1800 plus 9 square, 81. So 10,000 plus 1800, 11,881. That's your answer. 11,881. Let's say if it is 112 squared, what do you do? 100 plus 12. So 10,000, because it is 12. Now earlier we were taking 1200 directly. Now you have to double 12. This is 100 plus 12. Remember, 100 plus 12. So twice of B. Twice of 12 is 24. 2400. 2400 plus 12 squared, 144. And you're done. So 10,000 plus 2,400, 12,400 plus 144, 12,544. You're getting it? As simple as that. I want 123 squared. What do I do? 10,000. 23 will become 46, 4,600 plus 23 square, 529. And you're done. 15,129 is the answer. Addition. 10,000 plus 4,600, 14,600 plus 529. So 14,600 plus 529 is 15,121. Yeah. That's it. Just use the same technique. Now, let's say I have to find out something lesser than 100. Between 80 and 100. 84 square, let's say. What happens? This becomes 100 minus 16 whole square. Technique remains the same. 10,000, the first term is 10,000. Because it is minus 16, it becomes minus 32. Double, right? 100 is the base. When the base is 50, take b into 100. When the base is 100, take 2b into 100. Similarly, when the base becomes 150, we'll have to take 3b into 100. And so on. I mean, when you expand the technique for bigger numbers, you'll realize 4b into 100 and so on. If you understand this pattern, you're done. Because first term will always be depending on what is a. Last term will be always b square. Second term will depend on this. So 100 square 10,000 minus 2b into 100. So 2b is 32 minus 32 and 100, 3,200 plus 256. Remember, the third term remains positive always. So 10,000 minus 3,200, 6,800 plus 256, 7,056 is your answer. You're getting it? 10,000 minus 3,200 is 6,800. 6,800 plus 16 square, 256. 6,800 plus 256, 7,056. I have to find out 96 square, let's say, or 91 squared. 91 is 100 minus 9. So 10,000, since it is minus 9, it becomes minus 18. Minus 1800 plus 9 square, 81. So 10,000 minus 1800, 8,200 plus 81, 8281. That's your answer. You're able to follow. I need, let's say, 89 squared. How much is this? 10,000 minus 2,200. It is minus 11, right? 100 minus 11. But instead of minus 11, I should take minus 22. So 10,000 minus 2,200 is 7,800. Plus 11 square, 121. 7,921 is the value. 7,921. You're getting it? 100 minus 11, so 10,000 minus 2,200, 7,800 plus 11 square, 121, so 7921, 7921. I hope all of you are able to follow. I mean, as simple as that. See, initially it may sound a little difficult or appear to be a little complex, but remember that the technique is so generic that you can always apply for any number. I mean, I can also find out 853 square using this technique, and in about 5 seconds, not more than that, without putting pen on paper. Without putting pen on paper, right? Otherwise, techniques are like have got their limitations. Like I'm sure some of you will say, why do I have to do 91 square like this? I have a better technique for 91 square. I can explain you. I told you, right? It's the same calculation can be done in multiple ways. Instead of taking 91 square in this fashion, I am hoping some of you know about the other technique also, right? 91 square can also be taken like this: 90 squared plus 90 plus 91. 90 square is 8,100, 90 and 91 is 181. 8,100 plus 181, 8,281. That's what we'll get. Yeah? Like 109 square was required, right? Here also there is a special technique, right? 109 square can be taken as 110 squared minus 110 minus 109. He'll give you 11,881. But these techniques have got limitations, right? I mean, only when it is one more or one less or two more or two less than the number ending with 0 square. Otherwise, not applicable. What we are discussing is very generic, applicable always. Right? So this is how you can find out squares of numbers beyond 80. Now, this would be applicable up to 130. See, 100 is the base, right? So 100 plus 30, up to 130 you can do it. Now again, why are we able to do it only up to 130? Because I know only 30 squares. If I know up to 40 squares, I can apply up to 140. You have to put you have to draw a line somewhere that I will not learn more than 30 squares. I am done with 30 and I'll apply the same thing for, I'll use this for finding out squares. You can learn up to 40, nothing wrong in it. But then why up to 40 only? Learn up to 50. But if you learn up to 50, I'll say why up to 50, learn up to 60. Because somebody here mentioned, right, that we can take it as, I know up to 99 squares by heart. But where do you want to stop is the question. I would say stop at 30. Enough. More than enough. What happens if it is more than 130? Take 150 as the base. As simple as that. Yeah. For example, I want to find out what is 153 square. Do I have to put pen on paper? I'm not putting it on paper. I'm sure you can use the same technique. Expand it yourself. I mean, there's no point in me explaining this to you. But then take the base as 150, right? So I want 152 square, let's say. Not 153, 152 square. What happens? 152 is 150 plus 2. Now 150 square. See, remember, 50 square gave you 2,500. 100 square gave you 10,000. 150 square will give you 22,500. Because 15 square is 225. 150 square will be 225 with 100. So 225, 100. 22,500, right? So the first term now is 22,500. Second term will be 3b into 100. See, with each 50, the multiplication factor increases by 1. When it was only 50, b into 100. When it was 100, meaning 2 50s, 2b into 100. When it is 150, 3 50s, right? So 3b into 100. Number of 50s. Look at the number of 50s. Change the understanding, right? it is all based on number of 50s. With each 50, the multiplication increases by 1. Yeah. So that's how it works. Then, so if it is 150, 150 is 3 50s, right? So 3b into 100. And then b square. Last time is b square. So do that now. 152 square, 22,500. Now you have to remember these terms, right? If you can't remember, then it becomes difficult. 22,500. 3 terms you have to remember, right? To merge. So 22,500. Now, what is b? 2. But since it is 350s, you have to take 3b. So 3 into 2, 600. So 22,500 plus 600, 23,100 plus 2 square, 4. 23,104 is the answer. As simple as that. No? Yes? It may sound a little complex, but understand that you're doing it for the first time. When you practice a little bit on this, you're through. I want 153 squared. Or 153 and 152 are like almost similar, right? Let's take 161 squared. Complex, huh? No. Takes 5 seconds. 5 seconds now because when I'm reading it out and all that. Otherwise you can do it maybe in a second faster. Yeah. So 161 squared. 150 plus 11. 161 is not 160 plus 1. Remember, don't tempt to take it as 160 plus 1. If you take 160 plus 1, then you are screwing it up, right? You are better off taking it as 150 plus 11. 150 plus 11. Now do that. 22,500 plus 11, right? It becomes plus 3,300. 3 times. There are 350s, so I'll multiply B with 3. So 3 into 11, 3,300. Plus 11 square, 121. These 3 terms. Remember these 3 terms. 22,500 plus 3,300 plus 121. Now 22,500 plus 3,300 is 25,800 plus 121. 25,921 is the answer. I am reading it out. Takes a little longer. If I have to do for myself, keeping my mouth shut, I'll save a couple of seconds. And if I can do it that fast, you can also do it that fast. Practice is the only difference. Understand? Practice is the only difference. I have gone through a lot of, I have spent a lot of time on this. Lot of time as in what? 1 hour maybe overall. Yeah? That's how you do it. Think about this. I'm sure I don't want to expand 150 plus something, and you can use the same expansion. Understand that with number of 50s it increases. I want, let's say, 204 square. Is it complex? No, very easy. 200 plus 4. Now 200 square will be 40,000. See, 20 square, and you don't have to learn the first term also, right? Don't learn the first term by heart. No, not required, right? 15 square 225, so 22,500. 20 square 400, so 40,000. So 204 square, right? 40,000 plus, there are 450s here. 450s, so I have to multiply the B by 4. Multiply B by 4. What is B in our case? 4. Multiply by 4, 16. 1600s. 1600s have to be taken. So 40,000 plus 1600, 41,600 plus 4 square. B was 4, right? 4 square 16. So 41,616 is the answer. For what? 204 square. Yes or no? May bounce off for some of you if you have not followed it. If you are not able to do it, but practice. Do it coolly yourself. I'm sure you'll get it. Take as much time as you want initially. Get it right first. Get it right and then work on your speed. Right? Yeah, 41,616. I can see that some of you have got the answer as 41,616. So all you have to do is practice on this simple technique, and your life will become easy. Yeah. Let me take one more example, right? Let's say I have to find out 256 square. See, the same thing will work for minus also. Even if it is like, let's say I have to find out 191 square. Don't panic. 191 is what? 200 minus 9. That's it. 40,000 minus 9, right? Into 4 minus 3,600. So 40,000 minus 3,600. 46,400. Plus 9 square 81. 46,481 is the answer. Believe me, I have not memorized the answer by heart. I am doing it now. Here, right here. And if I can do it, you also can do it, right? 191 squared. So 200 minus 9. 40,000 minus 9 becomes minus 3,600. So 40,000 minus 3,600. 46,400 plus 9 square 81. 46,481 is your answer. Right? Now let's take one last question, which is more than 250, to see if this technique really works or not. It works, always works. 256 square, let's say. 256 square. Can you take it as 200 plus 56? No. Because if you take 200 plus 56, the limitation is I don't know what 56 square is. I know 56 square is 3136, but I don't want to know. I don't want to use that. Yeah. So 256 square, I cannot use 200 plus 56 expansion because 56 square is not known to us. We are not supposed to know 56 square. We are supposed to learn only up to 30. What do? Take it as 250 plus 6. You're done. 250 square, 62,500. 25 square, 625. So 250 square will be 62,500. So first term is 62,500 plus 6. Now there are, what is the value here? 250, right? How many 50s have you taken? 5 50s. 250 is like 5 50s. So multiply by 5. 6 into 5, 30. 30 hundreds is 3,000. Yeah, I hope you are able to follow. So 62,500 plus 3,000 plus 36. What is 62,500 plus 3,000? 65,500 plus 36, 65,536. 655, 360 is your answer. 256. 250 plus 6. 62,500. This is 5 times, so 3,000 and then 36. Close your eyes, get the 3 terms, merge. And you are there. Yeah. I'm kind of tempted to do one more calculation before I close it here, right? And I'll choose the number 309. 309. It happens, right? At least with me happens. I'm sure you also will have this thought that certain numbers remind you of something, right? Like 309 always reminds me of Virendra Sehwag's triple century, right? When he had first scored the triple century in Test cricket in Multan versus Pakistan, right? And then he got he got christened as Sultan ka Multan, if you remember, Multan ka Sultan. So anyway, 309 to me is like, whenever I see 309, it reminds me of Virender Sehwag, and I love him for his confidence. I've mentioned this like umpteen times in my live sessions, right? I mean, the one thing that we should all learn from Sehwag is that your first ball is the last ball. Hit every ball that you get, right? I mean, you should maintain that pace, right? Don't settle down and then hit a boundary. Hit a boundary and then settle down. Anyway, back to the number. So 309 square, what do we do? 300 plus 9, 90,000 plus 9 into 6, 54, 5,400 plus 9 square, 81. You're done. 90,000 plus 5,400 plus 81. 95,481 is 95,481 is your answer. You're able to follow. 309, 300 plus 9. I think we have taken too many 9s actually, right? But anyway, I'll like to close on 309, right? 309, so 300 plus 9. 300 square, 30 square is 900, so 300 square will be 90,000. 90,000 plus 9 here. Now 9 should be multiplied by 6 because we have taken 650s. 300 is 650s, right? So 6 into 954, so 5,400, right? 5,400. And the last term is 9 square anyway, 81. So 90,000 plus 5,400 plus 81. 95,481 is the answer. On that note, let me close it here. We come to, I mean, not really the end of squares. You have to practice a lot, right? What we have discussed is a technique, right? A technique which can be applied to all the numbers. So practice on this. I think this is only 10% of the job done, right? Only 10% of the job done. The 90% of responsibility is on you, right? Only when you practice, you'll be able to apply it. Any technique, this or any other technique that you just follow what suits you the best, right? I am not saying this is the best way to get the answer. This works the best for me, right? If you have a better technique, please follow that. But practice enough and ensure that you're able to apply whatever technique you have followed at the right time in the exam. Only then it makes sense. Otherwise, no point in learning too many things. So I would like to close it here. I want all of you to spend time on practicing this. Like I said, 90% is still on you. Only 10% of the job is done. So spend a couple of hours and I'm sure you'll be ready to find out squares of numbers, at least up to 3-digit numbers in a jiffy, like 3, 4 or 5 seconds maximum, depending on how big the number is. Don't worry about 4-digit numbers now. How do you find out 1,236 square? We'll do it on paper. Why do you have to worry about it? I mean, how many such numbers do we get in the exam in the first place? Yeah. So let's perfect these smaller numbers first, right? Let's work on these smaller numbers, right? Keep it simple. The KISS principle, right? Keep it simple and stupid, like they say. So let's keep it simple. Work on these techniques or any technique for these numbers, smaller numbers, and I'm sure we can save a lot of time in the exam and boost your score in the quantitative aptitude section. On this note, I would like to close it here. Thank you all for joining us. I wish you the best from the team TalentSprint for your IBPS PU exam tomorrow and day after. I'm sure you guys will do well. Remember, relax. Don't prepare now. Don't practice. Cut down your preparation completely. Just keep yourselves calm, cool, composed, and go and give your exam with that confidence, right? Full of confidence, right? We'll meet again next Friday, same time, same day, with yet another technique from speed math, maybe how to find out cubes or cube roots or square roots. Depends on what we think we should do that day. So see you again on Friday at 11 a.m. for your next session on speed maths. Until then, relax if you have your exam, otherwise keep practicing and take very good care of yourselves. Do not forget to subscribe to our channel to get alerts about these live sessions and the videos that we do, right, for your bank and SEC exam preparation, right? So hit subscribe button, which is right below this video, and get exam ready with TalentSprint's YouTube channel. Thank you so much for joining us. Take very good care of yourselves. I'll see you all in the next session. Bye.